Hello again. So today we're going to talk about solar energy. There is passive solar. There is solar thermal technology, capturing the sun's heat. And then there is photovoltaic or PV solar technology. First up, we're going to talk about passive solar design. So this is where you use construction techniques that are designed to take advantage of solar radiation without any active technology. So without using any pumps or other mechanical devices that would rely on electricity. And this stabilizes the indoor temperatures passively. And can also be involved in not just temperature but daylighting. So using more natural light instead of artificial light. The first element of passive design or passive solar is going to be where your windows are facing. So here's our windows. And in the northern hemisphere, you're going to want south-facing windows to take advantage of that sunlight to heat the house with the sun's rays. If you're at lower latitudes, you're actually going to maybe want some more western, eastern-facing windows. And then if you're in the southern hemisphere, you would want windows that are on the north-facing wall. Another element of passive design is to have some kind of absorber. So this would be a dark colored surface for the floor or wall to absorb some of that thermal energy. Could also be a dark colored roof to retain some of the heat from the sun's rays. Or if you're in a warmer climate and you want to keep things cooler, you would want a light colored material. The next piece is having materials that are of high thermal mass. These are materials like stone and concrete that are able to retain heat or cold. Another piece of passive design is circulation or ventilation. So you want the heat or cooling to be circulated through natural conduction, convection, and radiation. Part of this can be taking advantage of prevailing winds. So if prevailing winds blow from an east to west direction, you would want windows that could open on the eastern and western sides of the houses to allow for that airflow in cooling the house. Another piece of passive solar is in control. So this deals with roof hangings, trees, blinds, awnings, all things that could potentially shade the house to allow for cooling in the summer. Or in this case, you can see here you have this little awning that is blocking the summer sun from getting into the house. The summer sun is higher in the sky, so this awning will block that summer sun and cool the house, where the winter sun is lower and the awning is just at the right height where that winter sun will be able to enter these south-facing windows and heat the house. Trees near the house can also shade the house because in the summer they'll have leaves that offer more shade, and in the winter they will lose those leaves, allowing more light in that can heat the house. You can also get some daylighting through passive design. So using natural light by your placement of windows, you can have skylights that can bring in some daylighting, but that will also, if you have skylights in the roof, that will allow the summer sun in. So if you are trying to keep the house cooler in the summer, that might not be the best idea. When you're thinking about the design of your house, remember that the sun rises in the east and sets in the west. So you can kind of think about when you're using certain rooms in your house. So if you're in your kitchen more often in the morning and you want some natural light there in the morning, maybe put your kitchen on the eastern side of your house, versus maybe if you're in the living room more in the evening and you want some natural light there, having your living room on the western side of your house. Green roofs are also an option. So these are living roofs that can actually cool and insulate the buildings and also improve air quality by sucking up some of those pollutants. This is the California Academy of Sciences that uses a lot of passive solar design. They have some solar panels up on the top of the building. They use skylights for some daylighting and also to bring in some thermal energy. This building actually uses 30% less energy than the amount permitted under national building energy requirements. That's because of the natural light use, the way that the building is oriented, natural ventilation. They use recycled insulation, and they also have this green roof that you can see right here. Another option for solar is to use solar thermal technology. This is going to be capturing the sun's heat, so infrared energy. This is a solar water heating system, so it allows heat energy from the sun to be transferred directly to a water or another liquid, which is in these solar collectors here. And then that liquid is circulated to a hot water heating system here. So the heat is transferred to the water within that hot water tank. The circulation of the liquid is either driven by a pump in an active system or natural convection in a passive system. And if you have an area that it's experiencing freezing temperatures, you would want a non-freezing circulating liquid, so not water. And then you would just transfer the heat from that non-freezing circulating liquid to the water in the storage tank. This gives you an idea of what solar irradiation looks like globally. So some areas are going to be a lot warmer than other areas, so might be a little bit more easy to do this solar thermal technology. The next solar system is probably the one that you're most familiar with, and this is a PV system or photovoltaic system. And these are your solar panels. Solar panels are capturing energy from the sun as light energy, not heat, and then converting that light energy directly into electricity. Kind of like how plants will capture light energy and then transfer that light energy, convert that light energy into glucose. These photovoltaic systems, these solar panels, are using semiconductors, which are very thin, ultra clean layers of material to generate a low voltage electric current when exposed to sunlight. So if you can see in this diagram, the N-type silicon has free electrons, the P-type silicon has absence of electrons, so when they come into contact, you get the movement of electrons, and then that movement of electrons is what is generating the electric field. This generates a low voltage direct current, which is then converted into a higher voltage alternating current. And this is typically 12 to 20% efficient at converting sunlight energy into electricity. Move this over here. There are different types of solar panels. There's a tracking solar panel that tracks the sun as it moves throughout the day. There's a static flat solar panel, and then there's an angled solar panel, and these are what the power outputs look like over time. So obviously tracking solar panel is going to be the most consistent power. If you're kind of interested in this, go check out the video that I linked in the topics page about the Smart Flower solar panel. The majority of solar panels are tied to electrical grids, so any extra electricity that's generated and not needed at that moment gets sent to the electrical utility, and then that electrical utility will buy it or give credit so that when the sun's not shining, person with the solar panel can then just use that credit. So if you're off the grid, and this is your only source of electricity, you have to have batteries to store that electricity. So this is approximately the surface area globally that would be required to power the world with zero carbon emissions only using solar. And you can see if you've got these little areas, this is the yellow, this is a 2030 projection. So it's these little areas of yellow that it's talking about would power the world globally. And if you're interested in the paper that came up with these calculations, it's also This is a look at the solar roof that Tesla has come up with. So you've got these different types of solar roof tiles. These are all little mini solar panels. And then their idea is to tie in that solar roof here with having this electric car so that your electric car is running off of 100% renewable energy. One last type of solar technology to talk about is concentrating solar thermal. So CST, concentrating solar thermal electricity generation. CST is a large-scale application of solar energy, thermal energy, to electricity generation. So this uses a whole bunch of lenses or mirrors. You can see them here and then here. Right? And all of those lenses and mirrors and tracking systems focus the sunlight that falls on them on this large area, so all of this area, into a small beam here and here, so this receiver. So it's tracking all of the sunlight that falls on all of these mirrors into one spot, this one receiver. So it's essentially like a giant magnifying glass. And then it sends this heat of concentrated beam into this receiver, and then that heat is used to evaporate water and produce steam, and then that steam turns a turbine and generates electricity. So this is one case where you're doing steam production from the sun rather than fossil fuel or nuclear. Part of the problem with this is you need a really large amount of land, and you're unable to generate any electricity at night, obviously. So a 35 megawatt plant in California would cover 160 acres of land. This picture here is from a plant in Spain. So let's talk advantages of solar energy and disadvantages. So some advantages: no CO2 gets produced, no air pollution. You can generate hot water and electricity. When you have hot sunny days, that's when you heat, and hot sunny days are going to be the best for producing electricity using solar power. And then these are pretty economically feasible on a small scale. So the initial cost gets paid back pretty quickly. Some of the disadvantages: there is an initial cost up front, even though it will get paid back. Another one is that there are parts of the country where average radiation, solar radiation, is low. So you can see here's a map of the country, and you're going to get really high radiation in Arizona, Nevada, Southern California, but not so much in the Northeast. Another potential disadvantage is in the manufacturing of the solar panels. So it uses some energy and water, and then you have a variety of some metals and some industrial chemicals being used. And then also the batteries can be problematic. So manufacturing the batteries, disposing of, recycling the batteries, energy losses during charging, storage, recovery of electricity in the batteries. Battery technology is getting better. There's a new battery out there made of silicon now that is really promising in terms of its efficiency and being able to store more energy in a smaller size, and then less toxic materials, less heavy metals, but not widely available yet. It actually will be less expensive as well. So the end of life, reclamation, recycling of solar cells, batteries, that lifespan still needs to be increased, but we're getting there. So that's it for solar power for now, and next time we'll get into wind power, hydropower, geothermal, and biofuels.